Okay, geometry. If you can't tell, I'm sick, got a cold, and got some pretty nasty pink eye. I don't know how well that's going to come in camera, but it's definitely there. Anyway, I am going to walk you through the last steps of this project. Um, I'm going to do a very quick recap of what we did on Friday, and you're going to need to work together. You need to ask classmates. You cannot be passive today. You cannot wait. You got to go find people who know how to help you. And if you're someone who can help someone else, get off your phone and make yourself available to people today. There are only 5 days left, and we need to work together to be successful. Yeah. Anyway, please be active today. Even if you feel like you're done, I don't care. Be active. Be active with others, help others. Go check in with people. Go check in with your friends. Make sure everyone's on track. That'll go a long way today. And keep each other accountable. Don't get off task. Put away your phone. All those things. Now, I'm going to show you how to finish the project. So first, just to recap of what we did is we went around and we took a tape measure like this. And instead of measuring the distance toward an object, we measured a distance like in a different direction. That's the indirect distance here. And then we took a pointing device. So we set this down on the ground like so. And then we took a pointing device and we put it both at, well, let me get it on screen here. So we both put it here at the end of the tape measure and pointed it at an object, and then went further in, not like 5 inches, but like 15 feet or something like that, and then pointed it back at that same object. And each time we did it, there was an angle that we used a protractor to measure. So we're using this protractor to measure, and we're making sure that it's accurate. Okay. And for each person, you were to do that measurement separately. You could use the same object, but you would have to relay the tape measure out in a different location. So your angles and all your measurements are different. Okay, so you can work together, but again, you're not copying measurements. It says right there, do not copy any measurements. They need to be your own. Okay, and then the second step was then to take the spot where the tape measure came to an end, this spot, mark it on the ground, and then hold up one of these and point it at the top of that object to help determine its height. And on the side here, it'll be able to read an angle between, it says 0 and 70 degrees. Okay. I'm just going to change the answer there because for my example, it should be between 0 and 70 degrees. That's actually, it only goes from 10 to 70. Oh no, 0 to 70. Those are the only angles you can measure on this thing. It goes in 2-degree increments. So if you're halfway between them, that's 1 degree. And so help each other read that. And that's the down, that would be called the angle of elevation. Whatever's red on here is the angle of elevation. But then we also measured how high this rotating spot, where it rotates around right there, that dot, how high that was from the ground. And that's what the height of the altimeter was. And so that is the data that we gathered. My indirect measurement, the 2 angles pointing at my object, and then what was my angle of elevation? I tried to write 70 there, degrees. And then how high was this from the ground when I did it? Okay, and then, so if you've done that, and you've done it twice, because they're one on the left, one on the right, everyone's expected to do the whole page with their own data. Again, no copying any measurements. Then you're ready to do this page. If you're not, you need to get out there with your group and you need to get that data. Okay? And if you're struggling to get the data, if you forget, you need to pursue someone's help who knows how to do it. And you need to be willing, and if you know how to do it, please be willing to offer that help. This is our last project. There's plenty of time to finish this project on Thursday. Any last bits. But if you're coming in Thursday having not started it, not got any of the measurements, man, like like we're gonna move on. So, yeah. So please make it a priority to get moving today. There are only 5 class days left. You don't have time to make this up later. Okay. All right. And I should even say, even on Thursday, we will move forward, just not at the very beginning of class. We'll wrap this up and then we'll move forward. Okay, now, let me show you how this goes. So first, I would like you to draw a nice diagram, meaning use a ruler, okay? And so here I'm gonna draw like my tape measure, and I'm even gonna give it some thickness because the tape measure has thickness. Okay, here's my tape measure, there's the end of it. Okay. There's the other part of this tape measure coming out, right? And then I marked here's my end of my tape measure, and then right here might be my 12-foot mark, okay? Right? And then I'm going to have my object, say my object is a tree. Okay. And then from my 12-foot mark to that tree, I angled something there. And then from the end of my tape measure, measure something there. And this angle was 78 degrees. And this angle was 86 degrees in my example here. Okay. So this is an example of a drawing. And here's the end of my tape measure. And so the distance I want to calculate is this distance right here from the end of my tape measure to that object. That's what I'm going to try to calculate. Okay? Down here at the bottom, so we're just drawing our diagram. First, whatever D is going to be the distance from my object because that's where I'm standing to do my angle of elevation. So that's this. Now, that's for exceeding, is to measure your angle of elevation from that spot. If you decide to measure it from some other spot and just directly measure how far away you are from the object with a tape measure, that's fine. But that will be a meeting level, not exceeding level. Okay. And then this diagram, quite simply, will be me holding up what I guess kind of looks like a gun. For better or worse, it's just a little scope there thing, and yep, it's going to look like I'm shooting something. Okay. Okay. And I am looking up at this tree, this tall tree. Okay. And I'm pointing this, and let me get my... Okay. And then there is this, there is the ground, but then there's also this sort of horizontal piece right here that is 4 feet above the ground. And I'm going to mark this distance as 4 feet because that's how high I was holding the altimeter from the ground. And so that's what my drawing would look like here. Your drawing can basically look like the same thing, except for, my angle of elevation was 70 degrees. Okay, so I'm just drawing this information in a diagram. Yours would look the same, except for if yours is not a tree, it's a building, whatever, you draw that there. My height was 4 feet, your height will be different. There's my angle of elevation, but otherwise, basic principle holds, that triangle will be the same. Okay, now, let's work this out. Okay, now we're going to go ahead and write our equations, and we're going to solve this step by step. So once you've had all this information, you've drawn this diagram, you have this information, you've drawn this diagram, then we're ready to get going on the calculations. So the law of sines is going to be used on this first one. And the law of sines, the first thing we do is we calculate the third angle. It's always the first step. And to do so, all angles in a triangle have to add up to 180. So I take out my calculator and I go 180. And then I subtract these other angles. So 78 and 86. 78 minus 86, and I get 16 degrees. So that means that this angle up here is 16 degrees. So that's always the first step in the law of sines. Find the third angle. And then I'm going to write the thing I don't know, which is d. D over the sine of the angle across from D. So here's D. The angle across from it is 78 degrees. And then I'm going to write the distance I do know, which is this distance. This is 12 feet. Right there. So that's the distance I do know, divided by the sine of the angle across from it, and across from it is 16 degrees. Okay. Now to solve this equation, you first just type in what's over here. Please use these calculators. When I'm not there, because I know that these will default to degrees. You won't have some weird thing that gives you the wrong answer because they're radians and stuff. They're in a box on my desk. Put them back when you're done neatly, but they're there. Okay, there's plenty of them. I got like 20 something now. Okay, so all I'm going to do is I'm going to first just type in what it says over here with just the numbers. So 12 divided by the sine of 16. Okay, 12 divided by the sine of 16. Enter. It's going to spit out an answer. That's not my answer. To get my answer to find D, I just now need to multiply, because it's division. To undo division, I multiply. Multiply by the sine of 78. So I'm just going to hit times, and you'll notice at the top here it says ANS times, which ANS is short for answer. So the answer to the last problem, this times sine 78. Sine 78. Okay, and I get a distance of 42, and I'm going to round this to 2 decimal places because I'm still not to my full answers, but 42.58 feet. Okay, and if this is the spot I was standing when I did my altimeter, then the distance here is 42.58 feet. If I was standing at some other spot, I would need to measure the distance from the object from whatever spot I was standing in when I did that. Okay? Okay. Now it's time to update this diagram some more. So first of all, now I know that this distance this way is 42.58 feet. I also know, because this is an altimeter, that this is a right angle because we're talking about the vertical height of something. And this is the horizontal and vertical, they meet at a right angle. And so now what I have, and I'm going to draw it over here at this side just for clarity. You're not required to, but I'm going to draw it over here for clarity. I have a right triangle where the bottom is 42.58 feet, and this angle is 70 degrees. Well, if I know that, then I have a tangent equation to set up, because this is the opposite, this is the adjacent, and this is the hypotenuse, and I want to know how high that tree is. I want to know how tall that tree is, so I'm going to set up my tangent equation because it uses opposite over adjacent. Okay, so tangent equations go like this. The tangent of my angle, 70 degrees, equals the opposite side, which I'm going to use the letter P to represent opposite. You can use whatever letter you want. You can even write OPP for opposite, as long as you consider that one thing. And then on the bottom here, I'm going to write the adjacent, opposite over adjacent, 42.58. Okay. And then how do I solve this on my calculator? Well, this is a multiplication step. I just do, because divided by this, I just do 42.58 times the tangent of 70. So I go 42.58 times the tangent of 70, and I get a pretty tall tree, 116.9875 feet. But this is not the answer, because that just tells me that this distance right here was 116.99 if I round to 2 decimal places. 116.99, or basically 117 feet if I just round to a single decimal place. But that's not the whole height of the tree. I've got this other 4 feet that I was standing up above when I measured, so I have to add 4 feet. So I get this measurement plus 4 feet. And when I do that, I get 120.99 feet. This is just that amount plus that amount. And that's the whole process that I want you to do. You're taking the measurements, you're writing them down, you're drawing the diagram, writing the law of sines, solving the law of sines. If that's the spot you did your altimeter for, then that answer and that answer will be the same. And then you can go ahead and finish calculating this using the tangent equation, remembering to add this height to your answer at the very end. Okay. I expect you to do that process twice, once, twice, to help each other, to persevere, to grit it out, to rewind this video, to figure it out together. And when you're all done, please put all the materials back. Don't leave them out on the tables to get broken or lost or destroyed. Put them back on the table in a neat and orderly fashion as you found them. Okay. Third period, I'm letting you know right now, it was neatly organized. So if it wasn't neatly organized when you walked in, it was in first period. Please help it finish that way. I'm gonna see how well you do at keeping things organized. Okay, so that's what you need to do, and I'll see you on Thursday. If you want to get help, you can come in second half mentor group tomorrow on Wednesday to get help, or come in during lunch. I'll see you soon.